So Box2D has long been kind of the de facto physics engine for building games. And in the Flash world, we've always had a nice ActionScript port of that. Well, this now exists also for JavaScript. So if you want to do canvas-based games or just any type of physics simulation, we now have Box2D available in JavaScript. And in this two-part tutorial, I'm going to show you how to get set up with Box2D Web, which is the port we're going to use. And then also, we're going to see how we can apply that physics engine to CreateJS display objects to kind of give a physics simulation into CreateJS. So if you go to Box2D Web to the main Google code site, which is right here, you can actually obviously download the latest version. Now I've included the latest JavaScript file in the tutorial files, so you don't have to download it. If we look here, I actually have 3 files that are included, and this Box2D web.js is the latest version of this library. And then I have a starter HTML page and a main.js file. Okay, so let's go over to Sublime Text, which I'm going to be using in this tutorial. You obviously can use whatever editor you like. So in this game.html, I've essentially created a canvas with an ID of canvas. And I've also, after that, included the EaselJS, the CDN version of EaselJS. Now I've also set the background color of the body and the canvas here in a style block. And then on load, when the body's finished loading, we're calling a function called init. So what we're going to now do is to link up to that main.js file that I've also included. So I'm going to add another script block in here. And the source is going to be main.js. And let's also come under our EaselJS import. And let's go ahead and include that Box2D web.js file. So Box2D web.js. And these are the 3 JavaScript imports that we're going to need in our HTML file. Okay, so go to that main.js file that I gave you. Now this includes an object definition here called Box2D. And the reason that that's included, let me actually go back to the Box2D web Google code site. I'm going to go to the wiki and then basic usage. You'll see here that in JavaScript, we don't have a concept of importing packages and classes. There are frameworks that allow you to do that kind of stuff, but at its very core, you can't do that. So essentially, you don't want to have to write box2d.common.math.b2vec2 every time you want to create an instance of that. You especially don't want to do it when you get to some of these really long packages and class names. So here we have essentially shortcut variables, which are shortcuts to these classes. And so it's much easier for us to use B2 body as opposed to this whole package string. Now here, the author has actually recommended that we put this inside of a self-executing anonymous function to get it off the global scope, because you don't want these types of references to be on the global scope, because essentially what needs to happen, we need to traverse the entire scope chain when looking up these definitions. So I've taken that and just modified it slightly. What I've done is just created a variable or an object called Box2D, and then each of those shortcut properties are just created on that object. So this essentially creates a Box2D namespace. So I would say box2d.b2vec2 to create an instance of that. Okay, so with that there, we now have our Box2D namespace created with those shortcuts. Now, if you've never used Box2D before, one of the really quirky things is that it measures things in meters, which is obviously not, something you're going to work really well with in most computer simulations or games that you're going to use. So we need a way to convert that to pixels. So the scale to convert it is actually 30. So let's say we want to have a pixel value of 400. We're actually going to divide that by 30 to give us that value in meters so we can feed it to Box2D. So I'm just going to create a property here called scale and set it equal to 30. So anywhere in our simulation or our application that we need to convert, we're just going to divide it by scale. Okay, so now I need to create that init function, because remember, that's going to be called when our body is loaded. And what we're going to do inside of here is to set up our EaselJS world. So the first thing we're going to set up is the stage. So we're going to say stage is equal to new CreateJS dot stage. And here we need to pass in a DOM reference to our canvas element. So we're going to say document.get element by ID. And that actually has an ID of canvas. And I forgot the E. So get element by ID. Now you'll see this stage property, actually we're going to define it at the global scope so that we can reference it elsewhere. So we're going to say var stage. And another variable we're going to create is one called world. And this is going to be essentially our Box2D world. We're also going to create that here at this scope. And this is not really showing you the perfect structure for a real world application. Ideally, you wouldn't put anything on the global scope. But for our case, for our purposes here, this is fine. Okay, so now we've set up our CreateJS, our EaselJS stage. The next thing we want to do is to set up our physics world. So I'm going to offload that to a separate function called setupPhysics. And we're just going to ignore that for right now. Let's go ahead and just finish up setting up EaselJS. So what I now need to do is to set up my tick function. Well, I want to create a tick function here on the global scope and have that be my tick function. So to do that, I'm going to say CreateJS.ticker.add listener. And I'm just going to say this. This is now going to look for a function called tick here on the global scope. The next thing I'm going to do is to set the frames per second. So again, ticker set FPS. And I'm going to set it at 60, which is pretty high, but for a physics simulation, I want to get some nice smooth looking motion. Now another thing we can do with CreateJS is to have it use request animation frame. And if you don't know what that is, you can look back on my tutorial about JavaScript animation. And it's essentially an optimized way to create an animation loop in modern browsers. It's part of the HTML5 specification. So what we're going to do is to say CreateJS.ticker, and there's a Boolean property called useRAF. And we're just going to set that equal to true. Okay, so there's two functions, other functions that we need to create. First is that setupPhysics function. So setupPhysics. And the other is that tick function. So function tick, like that. Okay, so now we can begin setting up our actual physics world. So you can see we created this global variable called world. So we're going to instantiate that now. So we're going to say world is equal to new Box2D. And again, this is similar to the CreateJS namespace where we give the namespace and then the class name. And then we're going to say B2 world. Now to the constructor of B2 world, we need to pass in what gravity we want our simulation to have. Because obviously if there's no gravity, you could do other types of simulations, but we're going to do a basic one where we have gravity on the y-axis. So to define the gravity, we need to create a new B2 vec2, which is a vector2 object. So we're going to say new Box2D dot B2 vec2. And this just expects two numbers, the gravity on the x and the y-axis. So we want 0 on the x-axis, and we're going to give a gravity of 50 on the y-axis, so things are falling downwards. Now the next property is, do we want to allow objects to sleep? And if you enable this, it can improve performance because when an object has finished moving, it really can improve performance if you set allow sleep to true. So we're going to allow our bodies to sleep. Okay, so the next thing we want to do is to create our first Box2D object, which is going to be our ground, which is the floor essentially. So if we don't have that and we add objects to our scene, there's nothing for them to react to. So we need to create a ground object. So to do that, essentially, we need to create two objects. One is a fixture definition and another is a body definition. If you've used Box2D before, you know all about this. But essentially, the fixture definition is an object which allows you to set properties like density, friction, and restitution for your objects. So I'm going to create a variable called fixDef is equal to new Yeah, see, I have my snippet here in Sublime Text set to Box2D. It's probably not a good idea. So new Box2D dot b2 fixture def. And now with that created, we can just set properties on this. So for instance, I'm going to set the, let's say, density property equal to 1. And then I can set things like fixturedef.friction, how much friction this object actually has. And for that, let's just say 0.5. And all of these values are, you really need to experiment to get the kind of effect that you want. So that's the fixture definition. Now the next thing we need to do is to actually define the body. And the body is going to have properties like, what type of body is this? Is it a static body? One that's not affected by forces like gravity? In our case, our ground shouldn't be affected by that. So it actually should be a static body. And then also it allows you to set the X and the Y position of this object in the world. So we're going to create a new variable. I'm going to call it bodydef is equal to new box2d dot b2 body def. And now we're going to set some properties. So body def, let's first set the type. So we're going to say bodydef dot type is equal to, and essentially there's going to be two types of objects you're going to be creating, either static or dynamic. Dynamic will be affected by things like gravity. For something like a floor here, we want it to create a static body. So to get that, we say box2d, and then it's actually inside of the b2 body class. We say b2 body, and then it's b2 underscore static body. And that just tells Box2D that this is a static body. So now we actually want to set the position of this object in the world. So we're going to say position bodydef.position.x is equal to 400. Now that value is actually in pixels. So I need to divide that by our scale like that. So you're probably wondering, since our ground, we want to go all the way across our canvas, why we didn't set the position at 0. Well, that's because all Box2D objects, the registration point is in the center. So in order to make something go all the way across the canvas, we need to position it in the center of the canvas. And then for a width value, we're going to want to make it stretch on either side by 400. And that's going to fill things up. So it's another little thing you have to get used to when using Box2D. So now for the Y position, we want it to be positioned at the bottom of our canvas, which is 600 because it's 600 pixels high. And we'll divide that also by the scale. And we need to change this to Y. Okay, so we have the fixture definition, we have the body definition. Now we need to create the shape. What kind of shape is this object going to be? So to do that, we go to our fixture definition, and we go to the shape property, and we set that equal to a new box2d.b2 polygon shape. So we want to create this as a polygon because it's obviously going to be a box or a square. So box2d, and then it is b2 polygon shape. Now the next thing we want to do is to set this to be a box, because a polygon obviously could be anything besides a box. It could have any number of sides. So what we want to do is to say fixture definition dot shape dot and then call the set as box function. And this allows us to give the width and the height of the box. So our position is in the center of our canvas. So in order to get it to stretch the full 800 pixels from left to right, we need to set its width to 400. And it's going to do 400 on either side of that center. So again, anytime you're using pixel variables or pixel values, you need to divide by scale. Now for the height of the box, I'm going to have it stick up a little bit so we can actually see it. So I'm going to make it 20 pixels divided by scale, and that will actually make it a total of 40 pixels. So now we have this set as a box. We have our fixture definition, we have our body definition. Now the last thing we need to do is actually create our body and add it to our Box2D world. So to do that, I'm going to say world.create body and pass in that body definition that we created. This will now create a body into the Box2D world. Now we can chain a function call onto here called CreateFixture, which is going to create the fixture for this body based on our fixture definition, like that. So you can see that if you've used other Flash physics engines like Nape, the Box2D API can take a little bit of getting used to, but once you kind of get the basics, it's pretty simple from there. Okay, so we've created our ground object. Now we need a visual in order to see our objects. So in the next tutorial, I'm going to show you how to connect all this up to CreateJS display objects. But oftentimes you want to see the actual debug draw of the Box2D world, so you can see exactly the size and the shapes of your Box2D objects. So for that, we're going to use the debug draw class. So let's just say setup debug draw, and we're going to create a new variable called debug draw and create a new instance of that B2 debug draw class. So it's going to be new Box2D .b2 debug draw. And now we need to set some properties on this. So what this class does, it actually will draw those debug shapes into whatever canvas you provide. So we're just going to use the canvas that EaselJS is actually using. So what we're going to do is to call the set sprite function. And here we need to give the 2D context of our canvas. So to get that one, I can go to our EaselJS stage. So stage.canvas.get context, and we want the 2D context. So the next thing we can do is to set the draw scale. So we're going to set debug draw dot set draw scale. Well, for ours, we can actually just pass in scale for that, just in case you were using something besides 30. Now the next thing we can do is to tell it which actual things to draw into our canvas. Well, we want it to draw the shapes. We also want it to draw the joints, so we can see, obviously, if we have any joints and direction things are facing and things like that. So to do that, we say debug draw, and we call the set flags function. And now we just pass in essentially which things do we want to draw. And to do that, we go to Box2D .b2 debug draw. And to draw the shapes, we say .e underscore shape bit. Now to also get the joints, we're going to OR that with, and let me just copy this, save time. We also want the joint bit to be drawn. Okay, so now we've set up our debug draw. The last thing we need to do is to tell our world about it. So world.set debug draw, and we're going to pass in that debug draw instance. Okay, so now we need to turn our attention to our tick function, because remember, this is our CreateJS tick function. It's going to be called 60 frames per second. And inside of here, we need to do a few different things. Obviously, since this is EaselJS, what we first need to do is to update our EaselJS stage. Now, right now, it doesn't have anything on it. So it will in the next tutorial, so let's just put it in here. That will update our stage. The next thing we want to do is to tell Box2D to draw the debug data into our canvas. So we say world.draw debug data. And that will take all of the objects in our world and actually draw the debug shapes into our main canvas. The next thing we need to do is to increment or to step our physics world. So we say world.step. We provide 3 parameters. First, we provide our time step, and I'm just going to fix that to our frame rate, so 1/60th, to keep it in sync with essentially our main frame rate for EaselJS. The next is velocity iterations, and this is essentially where it calculates all of the forces in the world. And using a higher number for this will make a more accurate physics simulation. But actually, you'll see performance taking a hit. So these values are really you definitely want to trial and error. I'm just going to set velocity iterations and position iterations to 10. And position iterations is essentially the same thing, but it's instead calculating the position of objects in the world. So that's going to step our physics simulation forward. And the last thing we need to do is to clear any forces. So world.clear forces at the end of our tick function. Okay, so let's save this and let's see what it looks like. So now you can see immediately that things are working properly because I actually see the green floor. So static objects are going to be green here. So we can see that my floor is actually being rendered, and we can go to inspect element into the console, and we don't have any errors. So that's good. So now at this point, not very exciting because we've only added a single static object, which is our floor, into our world. So let's make it a little more exciting. So I'm going to go back to Sublime Text and go up to our init function. And what I'm going to do is right under Setup Physics, I'm going to listen for the mouse down event on our EaselJS stage. So stage.onMouseDown is equal to function. And every time we mouse down on the stage, I'm going to create a new Box2D circle shape. And unlike the floor or the ground, this is going to be a dynamic shape, so it is going to be affected by things like gravity. So I'm just going to copy this block right here because a lot of this is going to be similar. I'm going to paste this in here, line it up. So now ideally, every time you mouse down on the stage to create one of these objects, you wouldn't be recreating this fixture def and body def. But in the next tutorial, when we actually incorporate CreateJS into this, we're going to create this in a separate class, so it'll be a lot more portable and readable. Okay, so for the fixture definition, density, friction, we'll leave it there. What I'm also going to do is to set the restitution property. And this is essentially the bounciness of the object. And I'll just set it to 0.5, just so these circles are, a little bouncy, kind of like balls. Okay, so here we're creating our body def. Now the main difference here is the type. We don't want it to be a static body. We want it to be a dynamic body, like that. So that way it'll be affected by gravity. Now for the X position, what I want to do is to just give a random X position. So I'm going to say math.random times the width of my canvas, which is 800. And again, since that's a pixel coordinate, I need to divide by scale. For the Y position, I'm just going to set it to 0 because we want these to start at the top of our canvas. So now here, since we're creating a circle, we don't want to create a polygon shape because that's obviously not a circle. So instead, we're going to create a B2 circle shape. Now for this, we need to pass in the radius of that circle. So again, I'm going to pass in math.random. I'm just going to say times 100. And then need to divide it by scale, of course. It just gives it going to give that circle a random radius. Now this line we don't need because we're obviously not setting that shape as a box. So we can remove that. And we should be good to go. So let's go back over, refresh, and we can see, boom, I just dropped a nice circle. And you see that it turned from pink to gray. That's this actually falling asleep. So now this thing isn't really taking up a lot of processor time because it's asleep. Of course, it will come back awake once we add more balls into the scene, essentially. So that's where we're going to stop on this tutorial. In the next part, we're actually going to, again, take this physics information and apply them to EaselJS display objects.